of this warming, don't you think that these contrarians would quickly do their own analysis and show that there really wasn't any warming? Of course not, because they know very well. You know, they've tried to examine our data, and they did find one flaw, which turned out to be 3/100ths of a degree, and was an easily explained mistake. But that's the kind of thing. They're looking for nitpicking. They try to find small things, and then they question the integrity of the scientists. But in fact, there's the evidence for climate change and the analyses is very strong. It is true that in some of these email exchanges that some of the scientists did some things which I think they probably regret. I mean, for example, we should always make our input data available to the community, to anybody, so that they can check our analysis. But in fact, we've been doing that now for many years, and as I say, nobody can find anything that disproves our analysis.
Okay, well, one of the published emails we're talking about goes to the key part of the skeptics' argument that since 1998, the hottest year on record, carbon dioxide in the atmosphere kept going up, but the temperature didn't keep going up with it. Now, you've been bombarded, I understand, with scores of messages along those lines from people who want you to repent and admit that global warming is a hoax. So how do you respond to them?
You know, if you look at this global temperature curve and smooth it over a few years, you'll see that it's continued to increase over the last decade. And in fact, it's not true that 1998 was the warmest year. 2005 was the warmest year. The British analysis shows 1998 as the warmest year because they exclude polar regions, because there are no weather stations there, or very few. But there are other ways to estimate the temperature in the polar regions, and in fact, because of the decreased sea ice in the Arctic, it has been warmer and warmer in the Arctic. And when you include these polar regions, it turns out that 2005 was the warmest year. And when you average over a few years, you find that the temperature curve has continued up. And besides, you don't expect the temperature to go up every year. There's a lot of natural variability in the system, primarily due to the tropical El Nino, La Nina cycle. And now we're moving into the El Nino phase, so it's a pretty good bet that, first of all, this year is going to be one of the warmest years, 2009, and 2010 will probably be the warmest year in the record.
Is there already evidence for that? I mean, are you seeing early data from your global temperature recordings?
Yeah, we see the data up to now, and we know that the global temperature tends to lag a few months behind the tropical temperatures. So it's because the El Nino started a few months ago, it's likely to have its greatest effect on 2010, but it's already having an effect this year, making this year someplace between the 2nd and the 5th warmest. It depends on the November and December data, which we don't have yet.
Okay, can you tell us how the Goddard Institute takes and adjusts these global temperatures? Because skeptics claim that urban heat centres make a huge difference, that they distort global temperatures and they make it appear hotter than it really is. So do you adjust in your figures for the urban heat zone effects?
We get data from 3 different sources, and we now, in order to avoid criticisms from contrarians, we no longer make an adjustment. Even if we see there are 8 stations in Alaska and 7 of them have temperatures in the -30s, and one of them says +35, well, it's pretty obvious what happened. Somebody didn't put the minus sign there. Well, we don't correct that. Instead, we send an email or a letter to the organization that produces the data and say you'd better check the Alaska temperatures, because we don't want to be blamed for changing anything. But as far as adjusting for urban effects, we have a very simple procedure. We exclude urban locations, use rural locations to establish a trend, and that does the urban stations do have more warming than the rural stations, and so we eliminate that effect simply by eliminating those stations. But it's very clear that the warming that we see is not urban. It's largest in Siberia and in the Arctic and in the Antarctic, and there aren't any cities there. And there's warming over the oceans. There are no cities there. So it's not urban warming. That's just nonsense.
Well, if I understand you correctly, your biggest fear now is that these built-in temperature rises will trigger what you call feedback mechanisms. Can you explain how they work and what are the implications of them?
Yeah, well, that's what makes climate a really dangerous situation because of the inertia of the system. It takes the ocean a long time to warm up. It's 4 kilometers deep, and it takes ice sheets a long time to get started to move. They're very thick and have a lot of inertia. The problem is that as these changes begin to occur, and they are beginning to occur, Greenland is losing ice faster and faster, and Antarctica is now beginning to lose ice at a rate of about 150 cubic kilometers per year. As you get to a certain point, you can get to a point where the dynamics of the system begins to take over. If the ice sheets begin to collapse, by that time it's too late. You've passed the tipping point and the ice sheet is going to end up in the ocean. So that's one of the tipping points. Another one is methane hydrates. We're beginning to see methane bubble out of the tundra as it's melting. There's a lot more methane hydrates on continental shelves. As the ocean warms, that methane hydrate can also begin to release methane, which is a very strong greenhouse gas and can cause amplifying feedback, which makes the global warming much larger. And this is not idle speculation because we can look at the history of the Earth. And in past global warming events, we have seen those kind of amplifying feedbacks which then make the change extremely large.
Okay, well, you're talking about what you find from the examination of ice core data. Is there a comparable period in history, the history of the planet that is, where warming accelerates due to these feedback mechanisms? And do you get much more rapid sea level rises during that period?
Yeah, well, in the relatively recent paleoclimate, coming from the last ice age to the present interglacial period that we've been living in for 10,000 years, when that ice sheet, the big ice sheet on North America, began to disintegrate, sea level went up 5 meters per century. That's 1 meter every 20 years for several centuries. So once an ice sheet begins to melt and begins to disintegrate, things can move very rapidly.
Okay, let's go quickly through a couple of the other key arguments put forward by the skeptics. Why worry about carbon dioxide when water vapour is a stronger greenhouse gas and actually occurs naturally?
Yeah, that's the screwiest argument, which keeps being made again and again and again. The amount of water vapor in the atmosphere is determined by the atmosphere's temperature. Everybody should know that. Look at the difference between winter and summer. As you go to a warmer climate, the atmosphere holds more water vapor because at the places where the humidity reaches 100%, the water vapor falls out as water or snow. And therefore, as the planet becomes warmer, the atmosphere holds more water vapor. That's why we get heavier rainfalls as the planet gets warmer. So this water vapor is an amplifying feedback. It makes the greenhouse effect much stronger, but it's not something that just changes on its own accord. It changes in response to the temperature changes.
Okay, if I understand it correctly, your argument is that climate change is not only about droughts, but that effect you're talking about will cause much more frequent and much more severe storms. Is that correct?
Yeah. Both extremes of the hydrologic cycle must increase, become more intense as the planet